Alright, this is a video that's going to assist with section 8.3. Some of the videos the textbook has are either don't align with the 8th edition of the book, or the sound is gone on the video on a portion of the eProfessor still works, but the others don't. So I wanted to go through here and kind of make out some videos, kind of maybe help or a video. And so what I chose to do is I chose to go ahead and just take and make my scratch work for the whole entire piece. So essentially I'm going to post this scratch work right here, which has all of the calculations that you would need and so forth. That by this point we should know how to find each piece from the previous sections, and then this video will kind of tie it all together. So you'll have this as a reference to make sure that your work's aligning, and then we can work on it, and my video will focus on here whether it's one-tailed, two-tailed, and then whether we reject or accept the null hypothesis and so forth. So let's start off with one-tail and two-tail. So let's jump right into number 7. So here we are, we got number 7, we're reading through the question. What we need to understand here, what we need to think about is, a cell phone company. The average local cell phone call is reported to be 2.7 minutes. They take 20 sample calls, average 2.98, and what they want to know is at that significance level, can it be concluded that the average differs from the population? So what we have to visualize here in this particular problem that makes this a two-tailed test is that grab a good color. Here we go. So here we are. Here we are at the mean. So our mean and our normal distribution curve is going to be 2.27. Okay, we have a new data value, a new average for a sample that we took. That sample occurs at 2.98, which has a significance level of 1. Oops, excuse me, that was my mistake. So this is 2.093. So we have this established value above, but we also need to look at that established value below, because even though the data that we collected was for sample, what we're looking for is we're just looking for our for our average minutes to differ from the mean. So we also can go down negative 2.093. So we're kind of above, or we could be below. So what we're trying to figure out is, are we inside of this area right here? If we're inside of this area right here, then there would be no reason to reject. There'd be no change in our claim. Our claim would be is that our average is still 2.27 minutes. But if we're outside of that, if we're outside this critical value, this critical area, then we have evidence to show that, we can kind of say that maybe the average has changed since it was previously established. So we do our calculations, we find our t-value based upon what we have. Our t-value says that we have positive 3.24. Our t-value therefore is outside of that critical area, whether it be outside on top or whether it be outside below. It doesn't matter whether it's above or below. The point is that it's outside of this established area that we can say is safe, and so therefore we have enough evidence to support the claim that the average does differ from 2.27. And we'll come back to that claim in just a minute. So right now, why is this two-tailed? Because it doesn't have to be above, it could also be below. Let's take a look at number 9. On number 9, we see a situation where we're looking at the heights of the building. And in this case right here, we have in a large city, the average height is at least 700 feet. So in this situation right here, we're kind of going the other way. Like, we're actually saying, okay, we want to see if we are greater than the average, if we have established something that is higher. So our null, our claim, our established thing that we're saying right now is that there's enough evidence, that we want to look and see if we are greater than or equal to 700 feet. Alright, so, and that means that our alternative hypothesis would be that we're less than that. So we go through the process, we establish our critical value region. You can see here on our picture, we can see the critical value be at negative 2.62. Why is it negative, you might ask? Well, it's negative because of the fact that when we look at the situation, our average is 606.5. 606.5 is less than the average. Our average on this image right here 700 would be right here. So if we're going to do 606.5, that would be less than 700. This is our negative region of our graph. That's why it'd be negative 2.62. So we go and we find our t-value. Find out our t-value is negative 2.71, which means that we can reject our null hypothesis. We are not inside the safe zone. So, I call it the safe zone, meaning that we're good. This would be the safe zone. We are not in the safe zone. So we are outside that safe zone. That mark is set right there. That critical value right here, that negative 2.62, that's my critical value. I'm outside of that safety zone. I'm in this other zone. So now I know that what I have claimed is not going to be good. So I'm going to go ahead and reject that null hypothesis. One-tailed, once again, why is it one-tailed? Because we're looking at the other end of the spectrum. We only want to see what happens on one side. We don't care about the other way because we have established a claim. Okay, let's jump and take a look at one more, and we'll go ahead and stop and split that video up into two parts. All right, so number 13. So here we are, number 13, and we got this movie situation. We're going through, our key statement is right here if we're looking at one-tailed or two-tailed, and it says, can it be concluded that it costs more than average to produce an action movie? So we're now, that statement right there, that more than, that less than, that greater than, that whatever it be, we now have established that we're looking at one particular side. That makes this a one-tailed test. So to kind of finish up, to go through, so we go through the process, we find our critical value. Our critical value establishes this cutoff region. So now we've got this line set up. We find that, no big deal, using our table, and then from there we go on, we find our t-value. We find out our t-value is 3.06. 3.06 is outside of that region. Okay, so, but once again, our main thing was here, is it one-tailed? All right, let's add one more thing to this video real quick, and that is how do we read the table F? So I forgot to throw that in at the very beginning. So let's go back and take a look at number 7. So on number 7, we have a couple values we look at here. So we have our significance level of 0.05. We have our degrees of freedom, and we know that we're two-tailed. Okay, so we go to our table. So we have a significance level of 0.05. Oops, sorry about that. Let me hit pause for one sec. Alright, so we go and we have this significance level of 0.05. We have a degrees of freedom at 19 for this guy. So we come across and we say, okay, we got a two-tailed test, 0.05 significant level, and we scan down the chart and we see that our significant value, that we're going to use, our critical value, I guess in this case here, would be 2.093. So we can see here that that's where the 2.093 came from. It's two-tailed, that's why it's positive or negative. All right, let's take a look at number 9. So number 9, same idea. We've got a couple critical values that we're going to look at here, or important values I should say. So our first important value is our significance level, and our degrees of freedom is the second. So we've got a significant level of 0.025. This is a one-tailed test. We already established that, with a degree of freedom of 9. So let's go on back out to this guy. Put that up. So we have a significance level of 0.025. We have a degrees of freedom of 9. And so we can see that our critical value for this problem would be 2.262. So we go on back to our chart, or to our problem. Oops, number 9. And we can see that's where we get our 2.62. Sorry about that, 2.62 right there. Once again, we already talked about why it was negative, because our average was 606.5, which is less than the mean, and that's why we knew to use the negative critical value instead of the positive that came from the table. Alright, so I'm going to cut off right there, and then we'll pick back up with a second video. That way this video doesn't run too long.